Good morning, everyone. I'm Sumit Mathur. Today, I'm here with a new topic that is Cisco packet tracer. Using Cisco packet tracer just to see by the simulation that how network can be established and how those network devices will react when they connected onto the network. So let me share my screen so that further we can have a discussion over that. Just a minute. It will take time. Yes, this is my Cisco packet tracer that you can see. Now, when as a new person you are going to start this Cisco packet tracer, so very first you need to go on netacademy.com and you can go there and you can download this software from there. Then after simply you need to have your sign up. So just sign up with your email ID or your Google account, and then every time when you are working on this you just log in with the same id, and you can have that complete flavor of this Cisco packet tracer. So what we can see over here, this is the simple layout of this Cisco packet tracer. These at the left hand side, bottom side, we are having some icons. Now this icon is for network devices, so we can see the very first is device is known as that router. So you can see number of routers are here. Okay, number of routers are here. We can use any of the router. These are the switches, number of switches are there, and my favorite is this 2960. I will use this uh, as switch in my system. These are the hubs which we are having now. Some these are that wireless devices are also here. We can use these also in that kind of experiment. Securities firewalls are there. These are the end-to-end systems. So when I talk about end-to-end system, if I talk about computer systems, PC, laptop, servers, IP phones, TV, tablets. So we are having symbol for each and every type of end devices. Okay, and these are the components which is also available with us. These are the connectors which are available. Most we will use these two connectors in most. Very first is copper straight through, and second one is copper crossover. So whenever we are going to connect to similar kind of devices like two PCs, so there we will use this copper crossover. And if we are connecting to different devices like a PC to a router or a switch or a hub, so in that case we will use copper straight cables. Other cables are also available like coaxial cable, serial DC. All these type of cable are also available. So now we will simply see that how we can connect two computers very first in our journey of this Cisco packet tracer learning. So very first is this. Let's suppose I'm taking two PCs. This is my PC1, PC0. Sorry, the nomenclature of it, and we can change this name also. No issue. This is PC1. Okay, so while you just move your cursor over here and you will get the information about this computer system. Okay, so how we can go further with this complete configuration of it, I'm showing you. Just a minute. So as I said, simply scroll your cursor to it. It is showing device name, that is PC0. Okay, and it is also showing its model number. It is also showing its MAC address, and you can see it is not showing its IP address because yet we have not set that IP address. But yes, MAC address is showing. Now I want to take some more information about the system. Just click over here, and you can see this is my system and this is that CPU. Okay, so each and every information is available here. So what I need to do now, I just want to communicate, have create a network between these two computers. So what I need to do, I need a connector. So yes, we will take this connector. I will connect it from here. Just put it over here. This is showing serial port 230, USB 0, USB 1, and fast Ethernet, because this is the LAN establishment. So we will go on this fast Ethernet. So I'm dropping it over here, and and drop this the endpoint to this PC1 and connect with this fast Ethernet 0, fast Ethernet 0. Now this green symbol is showing that these two systems are connected. Further, we can see where these connections are provided. So just go here, you can zoom in. This is your CPU, and goes down, you will see this is your first Ethernet port. So this is the area where that LAN cable is connected to these system PC0 and PC1. So this is the simple snapshot of these two computers. Now I would like to make sure that these computers are reachable from each other. So for that, I'm going on to this system. Okay, I'm going on to this uh, desktop. Okay, very first I have to configure them. I have to give IP addresses to these two systems. So let's suppose I'm giving IP addresses 10.0.0.1. This is the IP address of the first computer, and its subnet mask is 255.0.0.0. This is my PC1. So I'm just going on to its IP configuration. I'm putting its IP address. So its IP address is 10.0.0.2. So this I have given the IP addresses. Also, you can see here I'm having placed node. So what I am doing, I'm simply putting it over here so that I can put its IP address. So it will be useful for me also to just remember IP address of each of the systems. So I'm putting this over here. So now I'm having these two systems, IP address is given. Now I would just want to see its IP address and its MAC address. So just go over here, just move on command prompt, and here I'm simply writing IP config just to see IP address of this system. So as I'm looking IP address of this PC0, so its IP address is mentioned here. You can see IPv4 address is 10.0.0.0, subnet mask is given. Now let's suppose I also want to see its MAC address. So for that, I'm simply writing ipconfig/all. So now you can see its physical address, that is the MAC address, is also given, that is 00D0.97A4BCC2. It is showing here. We can also see when we are going on, we are taking our cursor over here, so it is giving us the same. You can see this same MAC address is MAC address 00, it is also available there. Okay, so as we were talking that how we can move, how we can see that IP addresses and MAC address. Same, I would like to see more IP addresses. I mean, I want to see that from this system PC0, how I will move, or how I can connect PC1. So for the same, I'm simply using the ping command just to check whether that PC, that whose IP address is PC 10.0.0.2, it is reachable or not. So I'm simply writing the command ping space 10.0.0.2. So just enter. You can see uh, replies are there. I mean, this is how to check. We are sending a request message from PC0 to PC1, and we are sending 4 packets. So you can see ping statics for that next system 10.0.0. So the total number of packets sent are 4, and total number of acknowledgement which we received, that is 4. Loss is 0. That round trip time is also meant. What is the round trip time? That is simply uh, this is the time taken by this PC0 to reach on PC1. I mean, request forwarded and the acknowledgement forwarded from PC1 to PC0. The total time taken, it is known as round trip time. So that is also mentioned over here. So this is how we are connecting two computer systems on network, just to see that these two systems are now connected with each other and they can communicate by sending data packets. Okay, so this is the very first a simple demonstration of it. Now I would like to see that how I can use hub over here. Now what is hub? So as we know, if I'm talking about hub, so hub is a network device. Okay, it is a network device, and what is saying that it used on broadcast methodology. Now what is the broadcast? Let's suppose this is a computer, and it is having some information and it want to pass that information to other computers. So let's suppose these are the other computers, like this computer A, this is B, and this is C, and this is D. Okay, now let's suppose this B want to forward some information to all these A, C, D. So it simply use hub, it forward that request to hub, and then this hub will forward that request to A, C, B, or the data packet to A, C, B, and they will it will forward, and here it will forward, and then they will reply to this hub, and further that hub forward that reply to this B. So it do work in the broadcast medium, but yes, sometimes what happens, we want to forward that request to only a specific computer only, but yes, because we are using hub, so hub will forward broadcast to each and everyone. So this is a problem of this system, that we want to send to this this C only, but we will forward to each and everything, because this hub is not intelligent, it will simply broadcast, it never forward in the unicast method. So first we will see that how that hub can be established, and how that hub work, and how it is forwarding that data packet to each and every system. So now I'm making changes into this same system only. So what I can do, I'm using this symbol, that is the delete. So I'm using it, I'm breaking this connection break. Okay, now I'm having two systems, I will take few more systems into my into this demonstration. So these are my two systems. So I'm taking few more systems here, PC2, PC3, and PC5. So we are having total 5 system in our this layout. Okay, I'm also putting IP addresses of these systems. So this PC0 IP address is this one, PC1 IP address is this one, PC2 IP address is this one. I already copied it, so I'm simply putting it. This is IP address of this PC3, and this is IP address of this PC. Oh, so I'm having these 5 systems in my layout. Now I'm using a hub over here, because I want to show you that this how this hub will work. So this is hub, and I'm using this PT hub over here. I'm just get it, just drop it over here. Now what I want to see, architecture of this hub. So you can see this hub is having fast Ethernet port 0 to 5. That means it is total having 6 port available here. That means 6 devices may connected at a time. Okay, so you can see link down, 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 because nothing is established connected with it. So I'm moving on to this. You can see I'm making zoom in. So this is fast Ethernet 0. Okay, all these 1, 2, 3, 4, 5, 6, all these 6 hubs are here, and you can see this is the button. This is on and off button. So I'm this right now this is off. I can on. I can put it like this, and it will be off. So now this hub is off totally. So now we will see that how we will make these connections. So let me start. I'm using these connectors. So because you can see, as I mentioned previously, that this computer and this hub are two different devices. So for that, whenever we connect it into the system, we will use copper straight through only. Okay, just remember, when two different type of devices connected, we use copper straight through. So I'm taking it, putting it over here. I'm taking first Ethernet and connecting with this hub. Now you can see we are having total 6 ports are available there, fast Ethernet. So I'm taking fast Ethernet 0 over here. Then again taking this one, connecting with PC1, fast Ethernet 0, connecting to fast Ethernet 1. Again taking it, connecting the system number PC2 with fast Ethernet 0 to this hub, fast Ethernet 2. Again taking cable PC3 fast Ethernet 0, connecting it to First Ethernet 3, again taking copper state through, connecting it with the PC4, fast Ethernet 0, and here I'm connecting with fast Ethernet 4. So what has happened? All these five systems are connected with this hub, but this is the only connection which we have created. But yes, we have not assigned IP address. We only wrote over here, we have not still assigned PC0 and PC1. We already assigned in the while we were running the previous experiment. Now this PC2, so I'm again going desktop, I'm going on IP configuration, I'm giving its IP address. So that IP address is 10.0.0.2, sorry, 3. It is its IP address, so it is okay. Now I'm going on this PC3. Its IP address is this one, 1234. Going on to PC4, I'm giving its IP address. This is 10.0.0.5. It is its IP address. So yet yes, we assigned IP addresses to all these five systems. Now just see this green symbol is showing that it is an enable process. Okay, connection established. Now as I said that here we are having a switch on and off switch. I want to show you what is the impact of this switch. This is on this time, clicking, this is off. So you can see these red symbol are showing that this connection is not established because this hub is off. Now again click on it, hub is on. So yes, everything is okay right now. I want to see that is this PC0 is connected with PC4 by just pinging it. So I'm going on command prompt. This was a previous window. I'm simply writing here ping 10.0.0.5. Just enter and let's see what will be the output. Yes, it is done. 4 packets sent, 4 packets received. That means connection is perfectly created. Connection is done. Okay, that means we can connect. I mean, we already connected PC0 to PC4. That means we can forward any data packet from PC0 to PC4. Okay, so now let's see how these data packets will travel. So here we are having two modes. This is real-time mode and this is simulation mode. I'm changing into simulation mode so that we can see the simulation. Okay, and you can see here a symbol is given there. This is PDU, that means your data packet. So I'm just bringing it. Okay, and I bring it and I drop it on PC0, and I want to forward this data packet to PC4. So I have just put it over there. So you can see in the bottom it is mentioned in process. In process, that means it will yet to start to send the data packet. As I said that when I will start it, this data packet will reach to this hub will forward that data package to all these four system. Among these all four system, that data packet is designed for PC4. So PC4 will accept it, and other three system PC1, PC2, PC3 will destroy that. Okay, then this PC4 will reply, that will reach to this hub, and hub will forward that reply to all these four systems, among which only and only PC0 will accept it and all other will destroy it. So let's see how it is how it is in working condition. So I'm clicking on display. So you can see data package reached to this hub. Now from this hub it is moving to all these four systems. So all these three will discard it, only it will accept. Now it will forward that acknowledgement. This acknowledgement will reach to all these four. Among these four, these will discard, only it will accept it. So this is that working of hub. Okay, I think it is all I mean, in a very simple way I explained it, so it is very much easy for you people also to understand that how this hub is working. And you can see here what is mentioned: successful means that data which we forwarded from PC0, it reached to PC4, and PC4 given that acknowledgement and it reached back to PC number 0. So source is PC 0, destination is PC 4. The type of packet we are using, that is internet control message protocol, that you will see when you will go with the IP addresses, that network layer. So this is one of the network layer protocol that you will study in your theory papers. Okay, so this is done with the hub. Now we are going with the switches, that how those switch will work. So as I said, that switch is similar to this hub, only the change which I can say, that switch is very first, it is smart. Okay, it is smart device. So if you're intended this, if this is a switch, and these four are the systems like A, B, C, and D. So if you intended to, if you want to forward a data packet from here A to C only, so it will forward to this switch will forward to C only. Okay, and C will reply, and this reply will reach to this A. But yes, switch may work as broadcast device, as I can say unicast device. It can work for both. But yes, your switch is having memory which store MAC address of all these 1, 2, 3, 4 systems. So whenever we will start it, you will see first it will react as a hub in the first case, and after that, because it save the MAC addresses into the memory. So in that case, when you will forward the second packet, then it will work as switch. No functioning of hub will be displayed over there. So let's see how it works. So again, I'm moving on to this Cisco packet tracer. Into the same experiment, I'm going to make some changes. So only this device, this hub. So I'm simply deleting this hub. So you can see hub is deleted. This data packet I'm also going to delete. So your data packet is also deleted. Now in my system, I'm having these five these five computer systems are available. Okay, so now I want to take a switch. I'm going on to this network devices, I'm going on to this switch, I'm taking 2960 switch. So this is my 2960 switch. You can see I'm clicking over here, I'm zooming it out. You can see that total 24 computers may connect at a time with this switch. Now these are the Ethernet portion where we can insert the LAN cable. So these 24 systems may connected with this switch. Okay, so here we are taking only 5 IP addresses all already assigned in the previous one. So now I'm simply connecting it. So I'm using this connected because again, two different kind of devices. So I will use this copper straight through. Okay, so copper straight through, I'm using it. I'm connecting with this PC 0, first Ethernet 0. I'm connecting with this switch. Now you can see, as I said, that there are total 24 computers may connected at a time. So from fast Ethernet 01 to 04, total 24 computers may connect. I'm choosing this only. Okay, it will, you can see it is in red color. Okay, shortly it will be converted into the green when this connection is established. Okay, I'm taking the second one. I'm connecting this PC1 with this switch with the first Ethernet 02. Again taking this switch, I mean cable, connecting first Ethernet 0 with this switch. You can see slowly they are converted into this green, that symbol from red to green, it is converted. PC3 first Ethernet 0 connecting the switch first Ethernet 04, it is connected. Then taking the fifth one, I mean the last system, first and 0, connecting it with this switch, first Ethernet 5. So wait for a while so that we can have complete establish this connection completely. Now you can see this switch. So this is a switch among which these 24, we have used 5 ports where these 5 computers are connected. Okay, now we can see that how the further we can work with it. So again, I'm clicking on this PC 0. I'm going on command prompt. I'm simply want to see whether it is whether PC3, PC4, okay, 0, 1, 2, 3, PC3 is connected or not. So simply I'm writing this command PC3 means IP address 10.0.4, 0.0.4. So just I'm simply pinging whether this device is reachable or not. I just want to see. It will take time. So we have to wait till the time which it is going to take. Timeout. First data packet failed. Let's see what will be the other reply. It is taking time. We have to wait till the time it is taking. So now we can see that how this PC0 is connecting to PC4. So just a minute. Yes. So this is, I'm closing it. This is PC0 moving on with command prompt. Yes, this is PC 4 means IP address 4 means PC3. Okay. So let's see how it is working. So you can see it is reachable. 4 data packets sent from this PC0 and reach to PC3. Okay. So it is in working condition. Now let's see how that data packet will travel. So as I said that we will use this simulation mode for this work. So we are now in simulation mode. You can see all the things are here. Now I'm taking this data packet. Okay. I'm putting this data packet on PC0. I'm forwarding it to PC3. Okay, so you can see this is in progress. PC0 is the source and destination is PC3, and this is the color of the data packet, ICMP Internet Control Message Protocol. So let's see how it works. So I'm clicking on this start button. It is first reached to this switch. From this switch it is forwarded to this PC4. Now from this PC4 it reached back to switch, and from this switch it will reach to PC0. So it was our task, and you can see what is mentioned here. It is mentioned successful. That means the work is successfully done. So this is the basic difference between switch and hub. That hub forward, hub do broadcast, and this switch it generally do that unicast mode. Okay, so I hope this video, these three type of connections we have created, first between two computer systems, then using hub, then using switch. So I think these tasks are clear to you. I hope you will do at your own, and if having any queries, please let me know. Thank you. Thank you, everyone.